In this video, we'll be solving this geometry problem involving triangles, altitudes, and reflections. Okay, here's the problem statement. In triangle XYZ, XY equals 20, YZ equals 15, and XZ equals 25. Y is reflected over XZ to Y prime. Find YY prime. Okay. So before we begin, let's go ahead and see about this reflection term that they're saying here. Let's make sure we understand what they mean by reflected over XZ, the line segment XZ. So as you can see here, we have XZ, the length 25, and it appears to be the hypotenuse of this here triangle. So when we reflect a point over a line, XZ in this case, what we're going to do is we always have to find, well, what's the perpendicular line that cuts across the line we're reflecting over, in this case XZ. So we must find the perpendicular line to XZ, which is this here, I've drawn it, that comes off of Y and forms a right angle with the line segment XZ. That's definition of a perpendicular line. So, because we have this line, that tells us that with any reflection, the reflected point must be on this new perpendicular line I've drawn here. We're going to call this line YY prime, because on the other side of it, we're going to have YY prime. Now, you have to have YY prime not just on the same line. It has to be in a very specific position on the other side of the line. We have to have the Y prime reflection must be the same distance away from XZ as Y is from XZ. So we have this distance, which must be the same as this distance. It's a reflection. It's on the same line, and it's flipped. It's the exact same distance. We aren't changing anything else. We're not doing any translations or transformations here. So, in order to find out the red distance here and the combined distance, which is what they're looking for, y prime, we must leverage the fact we're dealing with the right triangle here. And in fact, they tell us all the side lengths right here. So we have 20, we have 15, and we have 25. Now, one of the first things we want to do whenever we see a right triangle with side lengths that don't seem like they're familiar in any way is to see if we can factor a common ratio down to these side lengths to get them into their simplest term. So we see that all three of these numbers are a multiple of 5 here. So 20 is a multiple of 5, and so is 15 and 25. So we can say we can divide each of these numbers by 5. So we have xy is 4, yz equals 3, and xz equals 5. So we have 3, 4, 5, and that right there, as you might know, is a 3, 4, 5 right triangle. So we have yz is 3, really, and when you simplify it down, yx is 4, and xz is 5. So, but we don't need to use this fact. In fact, we could just use a much simpler way to really solve this problem. We could recognize that, okay, if the area of this triangle is x, let's say, that means we have an altitude that we can do base times the altitude divided by 2 to get to that x, that area. So if we see that one of the lengths is 20, and the other leg is 15, to find the area, we can do 20 times 15 divided by 2 equals 150. So that's the area of the triangle. Alternatively, you can do 4 times 3 divided by 2, then scale that up by 5 to get to your answer. Now, if the area of the triangle is 150, that tells us that if we have an altitude, we're going to label this P. If we have an altitude YP, where P is on the line XZ, so that YP is in direct perpendicular altitude, like we said before, that tells us that 25, or XZ, times YP divided by 2 must also be equal to 150 because they're the base and altitude of the same triangle. So obviously they must have the same exact area. So we must have 25 times x, whatever our YP length is, divided by 2 must also equal 150. So that tells us right there that yp, or x, must equal 12. We can confirm that 25 times 12 is 300 again, and 300 divided by 2 is indeed 150. So that tells us yp is equal to 12. And that right there, yp, is half of the total perpendicular line of our reflection. That's one side of it. Now, as we know, as we stated before, py prime must be the same length as yp because it's a property of reflection. Py prime must also be 12. So they want to know what y prime is. So that tells us all we need to do is do 12 plus 12 equals 24, and we have our final answer for y prime. Now, yes, that was a pretty simple approach to do there. You could have also leveraged the 3, 4, 5 triangle approach and used that to make it a bit easier to calculate the area of the triangle. But then, you would have had to go back and scale things back up again, which it's error-prone and might be even more time-consuming in the end. So this here approach, where you don't even need to scale things down, and you simply work with the area of the triangle as it is probably going to be your best bet with this kind of problem here, where you have reflections and perpendicular lines. Okay, and that's it for this geometry triangles problem.